Hello everyone. In this video, we have seen the topic on circular queue. So in the normal queue, we have that we have a front and rear. The rear the rear next part should contain the null value. In the circular queue, it is in the form of the last element connect to the first element. Now we will recall the previous session. In the previous session, I have taught what is a linked list and what are all the operations we can perform on the linked list, like traversal, insertion, deletion, searching, and updating, and also the types of linked list like singly linked list, doubly linked list, and circular linked list. So now we will understand what is a circular queue. The circular queue is a linear data structures. It utilizes the single and fixed size buffer. So it were connected end to end. This arrangement enhances the utilization of the memory efficiently, and also we can avoid the wastage of space. Now I will define what is a circular queue. The circular queue, it is a linear data structures. It is implemented in terms of an array representation. In the circular queue also, we have the two pointers like front and rear. We can insert the element at the rear end and we can delete the element at the front end. In the structure, the last element connects to the first element. That is the structure of the circular queue. And next we have the two pointers like front and rear. The front and the rear is keep track of the first and last element of the particular circular queue. We can insert the element at the rear part and we can delete the element at the front part. Next is that two main conditions are overflow and underflow. When you are going to inserting the element, first we have to check whether the queue is full. That is the overflow condition. Suppose you want to delete the element, we have to check what is the underflow condition. That is the two important updations in the overflow and underflow. So these are all the basic definitions of the circular queue. And also one more difference between the normal queue and circular queue is calculation of front and rear value. In the normal queue, we can calculate the next front position using front is equal to front plus 1. Just we are incrementing the front pointer. In the inserting, we can find the rear value, that is equal to rear plus 1. But in the circular queue, the calculation is only difference. Front is equal to front modulo of total number of size and rear is equal to rear modulo of total number of size. This is the difference between normal and circular queue. And what are all the operations we can perform in the circular queues are enqueue, dequeue, and peak operations. So what is the enqueue operation? Enqueue is a insert the element in the rear end, and dequeue operation means remove the element in the front end. So what is a peak operation? The peak operation is accessing the first element in the queue, that is a front element in the queue. So these are all the operations we can perform in the circular queue. So now I will explain what are all the basic pseudocode for inserting, that it means enqueue and dequeue of the circular queue. Suppose you want to do the enqueue operation means first step we have to check whether the queue is overflow or not. If not means next, if the queue is empty means front and rear points to the first index value, that is a 0. Suppose there is a element in the queue means we have to calculate the rear value using the statement rear is equal to rear modulo of size. So after the calculating, we have to insert the element at the particular position. So this is the way we can do the enqueue operation. So what is the procedure for enqueue operation means check the overflow condition, and suppose there is a place in the queue means next step we have to check the queue is empty. The queue is empty means front and rear is equal to 0. Next check, suppose there is some more elements in the queue means we have to find the rear value using the statement rear is equal to rear modulo of size. Next, on the particular rear position, we are going to insert the element of the particular queue. So this is the enqueue operation. And the next is the deletion operation, is called it as a dequeue operation. So in the dequeue operation, first condition we have to check the queue is underflow. That means the queue is empty. So the empty queue we cannot delete any element. So check underflow condition. If it is means we can just print, we cannot delete any element. There is no element in the queue. Suppose that condition is false means we have to store the front element in some other variable, and we have to move the front pointer. Suppose that in the particular queue there is only one element means we have to change the value as front and rear is equal to -1. That means automatically there is a one element, that element in the index value 0. So that element we can move the pointer, we can change the pointer of value of front and rear is equal to -1. Automatically means the index 0 element is reference is removed, so it automatically deleted. No, otherwise there is some more elements means we have to find the front value using the statement front is equal to front modulo of size. So the particular position, the front pointer should be moved. So this is the way we can remove the element or delete the element or do the dequeue operations in the circular queue. So what are all the advantages of circular queue is the memory efficiency. So the memory is fixed size instead of using the linked list concept. The performance of the particular enqueue dequeue is at 0 of 1 complexity. So these are all the advantages, and applications of the circular queue is it used in the buffer management system, traffic management system, and scheduling algorithm. In scheduling algorithm, we have a different types of algorithms, especially in the round robin algorithms, we can use the particular circular queue concept. Next is the communication protocols. That handles the messages or the packets in the network protocols means that communication protocols uses the concept of circular queue. So now I will conclude that what are all the topic we have shown for is what is the structure of the queue and what are all the operations we can perform in the queue, and what is the advantages of using the circular queue, and what are all the applications are using the circular queue concept. This is the things we are seeing so far. I hope that you will understand what is the circular queue and what are all the basic difference between the queue and circular queue and how the enqueue and dequeue operation is performed. Thank you.